So I want to reiterate some of the points that have just been made. So I won't go into them in depth, but just stress how important some of those things that are really not very exciting and not really by a lot of people thought to be essential laboratory components. But, I think, certainly, regular review of the safe work practices and the SOPs. I think it's forced a review of strategy, and you need to build on the learnings of the last 3 years. And, as the point was just made, that if you don't have the agreements in place for exchange of samples or exchange of virus, that is going to hold things up monumentally. And I've stressed throughout this talk that working in, collaboratively with clinicians and with hospitals and industry. So you need to identify who your likely partners are going to be and make sure that that sort of documentation is in place. Because with research agreements, with confidentiality agreements, with material transfer agreements, once you send it to a lawyer, you can add 6 weeks to 6 months to 6 years. So you need to have templates for those that the people you think you're going to work with have agreed on beforehand, and so it's written for virus X or cell Y, and then you insert the pathogen, and hopefully, there's enough corporate memory there that people remember that they've agreed that those documents are the template documents, and you can get them signed off for whatever the new pathogen is quickly, rather than starting from scratch. And so those things need to be in place, and similarly, I think, template protocols pre-approved by ethics for the collection of the collection and biobanking of samples with, template consents that an ethics committee can sort of pre-approve and have seen and have discussed with you, so that when you're faced with the next emergency, hopefully those things can happen much more efficiently, because those documents have, at least in principle, agreement and can be rapidly approved. I think the other thing is that, as I've said, we've worked very collaboratively. You really need to take a step back and look at those collaborations and look which one of those worked really well. How can you enhance and maintain those in less stressful times? How do you maintain those collaborations? What are you going to work on together to maintain those relationships? And also look at the collaborations that didn't work. Ask yourself why they didn't work. Are there things that actually are worthwhile trying to salvage from that, or do you walk away at this point because it's likely to never work? So again, prioritizing those things. And then really taking a step back and trying to decide where the future opportunities are and where you should apply the relatively scarce resources, which may become scarcer as we move forward because of the overinvestment that's occurred over the last 3 years. And if you have developed novel technology, how would you, can you develop that further? And I guess my view on that is that some of the work we've done is potential platform sort of technology, I'm looking at how we might develop that as a template for responding to phenotypic characterization of viruses going forward. And I think one of the ACIDS tests of this is, how much did you learn from this? Was your response to monkeypox any different to your response to SARS-CoV-2? Was it smoother, or was it just the same make it up as you go along response. And so, it's a sort of test case, I think, to look at how far, what you've learned, and if the response wasn't that different, you really need to make sure things that are in place so that it will be different next time. So, as I said, we've developed a suite of assays that allow us to, we've established, and a lot of this we learned from HIV, and so a lot of the collaborations we used for this were collaborations that we'd forged through HIV, and so we had the pre-existing personalised relationships there. So, we were pretty good at putting together clinical cohorts very rapidly, for putting linkage programs together rapidly. We've, as I've said, developed a rapid sequencing platform that's cheap and cheerful, which is not suitable for patient diagnostics and patient management, but is certainly accurate enough for public health responses. So it would never reach accreditation as a diagnostic sequence for something like HIV to determine resistance, but certainly in terms of determining what a variant is it's cheap and it's very rapid, and I'd like to think it's clever. As I said, we've got these now high throughput assays that allow us to phenotype the variants, and we've, a lot of this is modular, so it's rapidly adaptable. And so we can, marry up phenotype and genotype, and that phenotype includes, including growth characteristics and neutralization susceptibility, in about a week to a new Omicron variant. And we've adapted this platform to monkeypox very rapidly. And so, we're looking at whether the platform would be adaptable to other viruses of pandemic potential. So a lot of what we've built assays that we think are modular, and so we can clone in and clone out spike rapidly, and we can do that relatively cheaply now and rapidly. And as I said, we've also learned a lot about screening human cells for susceptibility. And so we have the ability to characterize viruses of different flavors in cells of different flavors very, very rapidly. And so that gives us great agility through this modular response. And I'll leave it there.